Alright, IGCSE team, we're looking at differentiation. We've done a little bit of this in class, so this is a bit of a recap. When we're differentiating x to the power of 6, we're going to take that 6, make it, times it by the coefficient of the x to the 6, which was 1, so 6 times 1 is 6, so it should be 6x, and then drop the power down to 5. For b, we're going to take that 9, so it's going to become 9x to the power of, drop the power down, 1, 8. C, that'll become 10x to the 9. D will become 7x to the 6. E, 0, that just drops out because there's no x term there. F, the power of that one is 1, so it's just simply going to become 1 times x to the power of 0, which is just 1. The G is going to drop out, as is the H. Okay, so they're gone. Now, we're going to try and find f prime x. Now, f prime x is just another way of writing dy dx, except we write it f prime x when we've been given a function notation. So it's differentiating when you've been given fx rather than y. Okay, so for this one to a, it should be 15 x to the power of 4. So we go 5 times 3 is 15, and then drop the power down of the x. For b, it's going to become 4 times 2, so 8. Drop the power down 1 to 3. The next one is going to be negative 10, 2 times minus 5, and then drop the power down to x to the power of 1, and we can just leave it as an x there. D, for this one, we're going to times that by 2, so 2 over 1/2 is 1, and then we drop the power down by 1, so it'll just be x. Next one is E. So this is going to be 6 times 2 minus 2/3, which ends up being negative 4, and then we drop the power down by 1. F, this is just going to become minus 5 because the 1 power times minus 5 is minus 5. So G, we're going to times that by 4. 5 quarters times 4 is just 5, so it's going to be 5, and then X, drop the power down by 1, 3. H, we're going to have 8 times negative 1/4, which is negative 2, drop the power down by 1 to the 7. So that's how we do those. Now sometimes we have something a little bit more difficult, like this one here, 3g. What I would do in this situation is expand the bracket. So, and if you take maths in year 12, I will explain to you another way that we can do these. But for now, we can write it like this. Now, when we differentiate that, the gradient function is going to be, we times the 2 here by the 1/2, so that just becomes 1, so we get x. And then the next term is just going to be negative 10 over 2, which is 5, and this one drops out. So that's that. Now, I think I've got a couple of word problems that we can talk about. And another one down here. Let's pull that up. Okay. Number 5. The coordinates of the 2 points on the curve, find the coordinates where the gradient is 12. So what we first do with these is we find the gradient function. The gradient function is going to be equal to, we drop the power down 1 times, so it's going to be 3x squared. Now, where is the gradient equal to 12? So what we now do, 3x squared is equal to 12. That means that x squared is equal to 4, which means that x is equal to plus or minus the square root of 4, so x is equal to plus or minus 2. Now, we are asked for the coordinates, so now we need to find the y values. So what do? Well, we put the y values into here. So y could equal either 2 cubed, which is 8, plus 2 is 10, or minus 2 cubed, which is minus 8, plus 2, which is minus 6. So the coordinates are 2, 10, or negative 2, negative 6. So that's 5. Now let's take a look at number 6. The gradient of the curve, find the gradient at the point where the curve crosses the y-axis. Okay, well, where does it cross the y-axis? when x is equal to 0, right? So therefore, the coordinate is 0, 1. We could just pop in zeros for those x's there. Now let's do dy dx. The gradient function is equal to 6x squared minus 2. Now, all we have to do is find the gradient at that point, and we chuck in the x value. So gradient at 0, 1 equals 6 times 0 squared minus 2. So the gradient should be minus 2 at that point. So with these kinds of ones, you put the x value into your dy dx, so into here for every x. The last question, a little bit more tricky. So what we have here is the gradient of a curve y equals to ax squared plus bx. And we know that the gradient at this point is 4, and we've got to find the value of a and the value of b. So first of all, we're going to go dy dx. So it will be 2ax. Remember, a is it's just a constant, and then plus b. That's the gradient function. Now, we know that the gradient at the point 3, 3 is 4. So what we're going to go is we're going to go 2a times 3, so we put our x value, plus b equals to 4. So 6a plus b equals 4. Now there's one other equation that we can do. We know this is a point on the curve, so we can go and use this equation here. So y, which is 3, equals a times x value, 3 squared, plus 3b. So we get 3 equals 9a plus 3b, and we can just divide everything out by 3, so 1 equals 3a plus b, and therefore b is equal to 1 minus 3a. Now we can substitute this into here. So let's go and do that now. We're going to have 6a plus 1 minus 3a should be equal to 4. So I get 3a plus 1 equals to 4, which means that a is equal to 1. Therefore, b is equal to 1 minus 3 times 1, which is equal to negative 2. Okay, and that is all I'm going to do from that exercise. I hope that helps, team.